Hello again, everyone. It is me, Mr. Ye, and today we're going to be covering the second half of section 5.3. Now, we covered the first half, factoring when a equals 1, when we have 1x squared, and we saw how to factor and solve quadratic equations in that case. Today, we're talking about some common ways to solve quadratic equations by factoring when a does not equal 1. So to start, we're going to look at this very special case. This is not super common, but it's also not uncommon. You will see this a fair amount. And it's called a difference of two squares. And so what does that mean? Well, difference means subtraction, right? Subtracting, and two squares, two perfect squares. If we are factoring and our starting quadratic equation is one perfect square minus another perfect square in this general form that I have written here, a squared minus b squared, we can always factor it to be a plus b times a minus b. The square root of the first thing plus the square root of the second thing, and the square root of the first thing minus the square root of the second thing. So showing a couple examples here, and keeping this equation on the screen, x squared minus 49. It only has two terms. We're missing that b term, that x term. There's 0 x's. Those are both really good hints that this might be a difference of two squares. And so I say, okay, so what is the square root of the first thing? Is it a perfect square? Well, the first thing is x squared. The first term is x squared. So square root is x. So I like just reminding myself, okay, so that's the square root. What about, is the second one a perfect square? Yes, it is. 7 squared is 49, right? So we recognize we have a difference. We're subtracting two perfect squares. And so what am I going to do? Well, there's kind of a shortcut I can take. I can go straight to my binomials and say it's going to be x plus and x, so x plus 7 and x minus 7. That's the difference of two squares, and it's a shortcut that you'll want to know because it'll pop up, again, decently often. A difference of two squares subtracting two perfect squares, square root of the first plus square root of the second, square root of the first minus square root of the second. And I'm not going to do this for everyone, but we can definitely check this. Think about what we would get if we foiled. We would get x squared minus 7x's, but then plus 7x's minus 49. The x's go away, and we would get x squared minus 49. So this is a formula, an equation that you will kind of want to know. Difference of two squares. Let's do another one. 4x squared minus 25. We're given this quadratic equation. We are asked to factor. Well, is the first one a perfect square? And it actually is. 2x, right? Because think about, what would 2x squared be? 2x squared would be 2 squared is 4, x squared is x squared. This is a perfect square. The second one, 25, is obviously the perfect square of 5. So we recognize it's a difference of two squares, and I know exactly how to factor it. Notice a is not even 1, but I still know how to factor this. The square root of the first thing plus on one binomial minus on the other binomial, the square root of the second thing. 2x plus 5 times 2x minus 5. A really nice kind of shortcut to know. Let's do one more. How about this? Factor this completely. And you might be looking at that and saying, wait a second, x to the fourth, that's not a quadratic. You're right. It's not a quadratic. It's a quartic. It's to the fourth power. But we can actually still factor this because 81x to the fourth is a perfect square. 9x squared would be, 9 squared is 81, x squared is x to the fourth. 16 is a perfect square. That one's numerical, so that's kind of easy. It's a difference we're subtracting of two perfect squares. So we're going to get the square root of the first thing plus on one binomial minus on the other binomial, the square root of the second. So square root of the first plus the square root of the second, square root of the first minus square root of the second. Difference of two squares. You might have noticed I said at the beginning of this problem, factor it completely. This actually is not factored completely because there is another difference of two squares inside there, look at that second factor, 9x squared minus 4. Well, 9x squared is a perfect square because 3x squared would get us 9x squared, and 4 is a perfect square. So I can actually factor that second factor and break it down even further. So the first one stays the same. Notice it's a plus. We don't have any way to factor a sum of two perfect squares. But this second one, I can break down into the square root of the first term plus and minus the square root of the second term. And now this is looking factored completely. 9x squared plus 4 times 3x plus 2 times 3x minus 2. This pattern, this difference of two squares, is something you're going to want to know and be on the lookout for, because it can save you a lot of time when you're trying to factor these. So hopefully these three examples kind of show you, again, if we have a difference, we're subtracting two perfect squares, square root of the first plus square root of the second times square root of the first minus square root of the second. That's our difference of two squares. Kind of a side note, but a really useful one to know. But what if we have problems that are not differences of perfect squares, and their leading coefficient is not just 1 or -1, where we could factor a negative out? We're going to use a technique, a factoring technique called grouping. Okay, so I'm going to narrate the steps, and you'll see some really similar steps to factoring how we learned it before, and you'll see some new steps. First thing to do, exactly the same as we did before. We're given this expression, 2x squared plus 15x minus 8, and we are asked to factor it. Well, the first thing to do is look and see, is there anything we can pull out, any common terms that we could factor out from all of them? And in this case, the answer is no. 2, 15, and 8 don't have any factors, common factors, greater than 1. And they don't all have x. That 8 doesn't have any x's to pull out. So here's what I'm going to do. Again, some steps will look similar. But the first thing I'm going to do is I'm going to come over here to the side, and I'm going to figure out what a times c is. Okay, a times c is what I'm going to be finding two numbers that multiply to be a times c. So I need two numbers that multiply to be -16. Again, the a is 2, the c is -8. Two that multiply to be that, and add to be b. So still just adding to be our b coefficient. So add to be positive 15, but multiply to be -16. And you might think for a second, and then you might stumble across, okay, what about 16 and -1? 16 times -1 is -16. 16 plus -1 is positive 15. So those are my two numbers. And here's where the strategy kind of diverges a little bit more even. I'm going to write my 2x squared and my -8 just as they were. But I'm breaking up that middle term. I'm breaking it up into plus 16x minus 1x. Again, using those two numbers that we found a second ago, 16 and -1. Why do we break it up? Why do we break? We're kind of unfoiling. We're unfoiling. You know how when you foil, the outer and inner terms that you get are often like terms, often have x. We're breaking this up so that now we can get to the name of the strategy, which is grouping. Grouping says, take a look at this first group, those first two terms, and just see, can I factor anything out of those? Answer, factor out a 2x, leaving me with x plus 8. We pulled 2x out of the 2x squared, so 2x, and we pulled 2x out of the 16x, leaving us with just 8. Now, can we group the next two terms and pull out something that will also leave us with x plus 8? That is the goal. So I look and I say, okay, I have x minus 8 right now, sorry, negative x minus 8. What if I pulled out a -1 from this second group? Pulled out a -1, that leaves me with x. The negative flips the sign. And now I have x plus 8 left over in both of those groups. And that means we're on the right track. Now we're golden because we're one step away. The final answer is going to be whatever we were able to factor out, 2x minus 1, times that matching leftovers that we had after we factored something out, 2x minus 1 times x plus 8. And this is our final answer. And we can check it. I'll check it, and then I'm going to recap and walk back through, and then we'll see some more examples. But if I check this, I can just, okay, FOIL it. So 2x times x is 2x squared, and then plus 16x's, and then minus 1x, and then minus 8. So 2x squared plus 15x's minus 8, and that's what we had at the beginning. So we know our answer is correct. Now, again, this is not a one-step problem. I mean, I should definitely see a lot of work shown for these problems. So what did we do? Well, first, we figured out what a times c was and what b was. And I needed to find two numbers that multiply to be a times c and add to be b, and they were 16 and -1. So that was kind of my first step, everything over here, if you will. Second step is rewrite my expression, breaking up that middle term into my two numbers, plus 16x minus 1x. And then my third step is group the first two terms together, see what you can pull out and what you're left with. Group the second two terms and see what you can pull out, see what you're left with. And hopefully you'll be left with the same thing on both, which means that's one of the factors, and the other one is whatever we were able to pull out. Let's try another one. Okay, so we're not just factoring now. This one we're asked to solve 4x squared minus 7x minus 2 equals 0. Starting in the same place, what is a times c? So 4 times -2 is -8. What is b? B is -7. Two numbers that multiply to be -8, add to be -7. You'll think for a second, you'll say 4s and 2s, that doesn't seem to work. What about -8 and 1? -8 times 1 is -8, -8 plus 1 is -7. So it looks like we have our two numbers. So now that we have the two numbers, we're just going to carry this down, 4x squared minus 2 equals 0, but we're going to break up that middle term, remember. We're going to break it up and say minus 8x's plus 1x, and that accounts for the minus 7x's we had up here. Okay, step 3, let's group. I could pull it looks like a 4 and an x out of this first group, leaving me with x minus 2. And you'll notice we already have 1x minus 2 on the second group. So what can we pull out? Well, if there's nothing else to pull out, we can just by default always pull out a 1, right? We could pull out a positive 1, leaving me with x minus 2. That doesn't change anything. So pulled out a positive 1. We have x minus 2 on both of them, which means we've got the things we pulled out as one of my factors, 4x plus 1, and then whatever was left inside, x minus 2 as my other factor. This is now factored, and we can FOIL it. We can check and we'll see 4x squared minus 8x's, but plus 1x is minus 7x's, minus 2. We feel good about the factoring. But this problem asked us to solve. So I'm going to come here and do exactly what we did last time in the first half of 3.1. I'm going to say, okay, we have two factors being multiplied to equal 0. Either 4x plus 1 equals 0. That's one possibility, meaning that subtract 1 on both sides, 4x equals -1, x equals -1/4. So that's one possibility. Or the other factor equals 0. So x minus 2 equals 0. Add 2 to the other side, x equals 2. So this is how we can factor and solve some of these problems that do not have a 1 out front. It's more than just 1x squared. And we can't pull that number out. We can't factor it. We saw that in the first half of 5.3. Sometimes we can just pull that number out. We're going to group. We're going to find a times c. We're going to find b. We're going to find what two numbers multiply to be a times c and add to be b. We're going to rewrite our starting equation if we're solving. We're going to rewrite it with that middle b term kind of broken up, and then we're going to group. We're going to pull what we can out of the first two terms, pull what we can out of the second two terms, and then write my factors, whatever I was able to pull out, and the leftovers that were left inside on both. Let's do a couple more. So write this one down, 3x squared plus 13x plus 12. If you want to, if the last two examples made sense, I'd really encourage you, pause the video, find your a times c, find your b, see if you can find your two numbers and factor this whole thing out. I see a typo really quick. I was asking you to solve, so this does need to be an equation. I'm going to make it equal to 0, okay? So if you're still with me, a times c in this one, 3 times 12 is 36, b is 13. So I'm looking for two numbers that multiply to be 36, add to be 13. 36 times 1, 18 times 2, no. 12 times 3, no. What about 9 times 4? 9 and 4. 9 times 4 is 36, 9 plus 4 is 13. So I'm going to say 3x squared plus 12 equals 0. And remember, we're breaking up that middle, plus 9x plus 4x. Group, what can I pull out of that first group? I can pull out a 3 and an x. And we're left with x plus 3 there. What can I pull out of the second group? I can pull out a positive 4, leaving me with x plus 3. So this is looking good because our leftovers were the same. They were both x plus 3. So what are my two terms then? 3x, and it was a positive 4 that I pulled out. So I'm going to say plus 4. And then whatever was left inside, x plus 3 should equal 0. Two factors, they multiply together and equal 0. So I'm thinking that either 3x plus 4 has to be 0, which means that 3x is equal to negative 4, which means that x equals, divide by 3, negative 4/3. Or x plus 3 equals 0, which means x equals negative 3. And there are my two answers. Really quickly, just to show you, you can check these. You know, I've tried to show you different ways to check these problems. Let me use the store function of the calculator. I'm going to say negative 4 divided by 3, negative 4/3, store in x. So there it is. And then I'm going to plug it into my original equation, 3x squared plus 13x plus 12. Does it equal 0? Yes, it does. We know that's a for sure answer. Let's just check negative 3 really quickly. Negative 3 store x. And then I'm going to grab what I just typed in a couple times ago with second enter. And that one also works. So I know I have my two answers correct. I've got one more problem. And so, I lied, I have two more problems. I'm starting to ratchet up the numbers just to show you, look, even though the numbers are getting bigger and more disgusting, we can still solve these with the exact same premise, same strategy. So first thing I'm going to do, I'm going to make it equal 0. And then I'm going to find my a times c. A times c, 9 times 16 is 144, and b is 30. And I don't know about you, I don't know all my factors of 144 super well. So maybe we just have to go test. I'm going to come to the calculator. I'm going to say, okay, what's 144 divided by 1? And we know that's 144. So could 144 and 1 be my two numbers? Answer is no, because they need to add up to 30. That doesn't do it. Okay, so what about 144 divided by 2? 72. So 2 times 72, could those be my two numbers? They multiply to be 144, but they add to be 74. So that's too high. And sometimes, especially if the numbers are really bad, you just have to do this. 3 plus 48, nope. 144 divided by 4. 4 plus 36, nope. But you'll notice we're getting closer to our desired target of 30. If you look at the calculator at the top there, we had 2 and 72. They had to be 74. That's a long ways away. 3 and 48. They had to be 51. Still pretty far away, but getting closer. 4 and 36. They had to be 40. We're getting really close. 144 divided by 5. That doesn't divide evenly, so I'm not really going to look at that. 144 divided by 6. 6 times 24 equals 144. 6 plus 24 equals 30. My two numbers, 6 and 24. So that means I'm looking at 9x squared plus 16 equals 0, plus 6x, breaking up that middle term, plus 24x's. So let's see what we got. Let's group. 9x squared plus 6x, I can pull out a 3x, leaving me with 3x plus 2. 24x is plus 16, I can pull out a positive 8, leaving me with 3x plus 2. Looking good, nailing it. So that means my first factor is going to be whatever I pulled out, 3x plus 8. And the second factor is the matching inside. And it's important that those match. I think I said that before, but it's really important that those match for grouping, whatever's left over inside. Equals 0. So solve it really quickly. We've got 3x plus 8 could equal 0. That's one of my possibilities. 3x equals negative 8. Divide by 3 on both sides. X could equal negative 8 thirds. Or 3x plus 2 could equal 0, meaning 3x equals negative 2. X could equal negative 2 thirds. All right, so we got some kind of bad numbers there, and it still worked out okay. I'm going to put one more problem on the screen, and this is kind of your challenge problem, okay? And hopefully, if you've gotten this far, it's making sense. If not, pause, rewind, go back, watch. I put some really gross numbers on the screen for this one. Step one, we're gonna make it equal 0, and then hopefully pull stuff out. But I don't see anything that I can pull out of 16, 48, and 27. They don't all have x's. I don't think I can pull everything out. Here's my challenge problem for you. We know that we have 16 times 27. We need to A times C. We need to find two numbers that multiply to be 432. And if I didn't know my factors of 144, I definitely don't know my factors of 432. I also need them to add up to be negative 48. Adding up to be negative 48, my B term. So here's my challenge. If you're feeling good, pause this. Take out your calculator. It might take a little bit to find two numbers that multiply to be 432 and add to be negative 48. But I challenge you. I challenge you to do it. This is harder than anything else you're going to see. Types of these problems. So worst numbers, disgusting numbers, try it, pause the video, and then come back and watch. If you're still kind of unsure, like I said, go back, rewind, watch some of those other problems before attempting this one, but do try to attempt this one on your own. Pause the video, see what you get, and then come back. All right, so at this point, I'm hoping you're back. I'm hoping you have an answer, you found it. I'm gonna come here and I'm gonna say 432 divided by maybe 6. 6 and 72 do not equal 48, negative 48. Okay, so it's probably a ways away from 6. How about 12? 12 and 36 do not equal 40. Well, they equal positive 48. So what about negative 12? 432, I know that if I take that and divide it by negative 12, negative 36 times negative 12, and those can be my two answers, negative 36 and negative 12. Those are my two numbers. Now, I did that kind of quickly. I went from 6 and I tried to explain my reasoning. 6 plus 72 is nowhere near 48. So that's why I skipped ahead to 12. It might take you a little bit of time. You might have to go 432 divided by 8. And say 8 plus 54 is 62. Not 48, but we're getting closer. And you might have to do 432 divided by 9. And so 9 plus 48 is 57. We're getting closer to our B value. You might have to do that a while, but hopefully you don't have to do every number. You can start seeing those patterns. I'm going to rewrite my original equation, except I am going to break up that middle term with my negative 36x's and my negative 12x's. All right, let's group 16 and 36. I think the largest factor I can pull out of there is 4x, I should say, because they both have an x, leaving me with 4x minus 9, 16x squared minus 36x. Yep, did that right. Group the second two terms, and I think I can pull out a 3, which leaves me with negative 4x's minus 9. And you'll notice the insides are not exactly the same. The insides here are not exactly the same, so got to figure out what's going on. How are we going to do this? I should note that when I pulled out just a positive 3, this would still be positive 9, right? To get our positive 27. So error on my part, sorry about that. Negative 4x plus 9 is what that one should have been. So they're really close. We got 4x minus 9, we got negative 4x plus 9. If all we need to do is flip the signs, let's pull out a negative 3. Remember, if we pull out a negative, all that does is make my 4x positive, and my 9 negative, it flips their signs and completely makes the insides match, and now we're good to go. Now I know that my two factors, 4x minus 3 times whatever was left inside both of them, 4x minus 9 equals 0, which means either this guy equals 0, 4x minus 3 equals 0, which would mean 4x equals 3, which would mean x equals 3/4. That's one possibility. Or 4x minus 9 equals 0, which means 4x equals 9 once we add it over, and x divided by 4 equals 9/4. And there are my two possible solutions. Exact same process as before, even though these numbers were a little bit rougher. So I had this challenge question in here to give you confidence and say, okay, I can do that. I mean, it's the same process. Maybe the longest, most time-consuming part is trying to figure out what two numbers multiply to be 432 and add to be negative 48. But we have calculators, we can use them for this. And this just shows that we can use this grouping method even if the numbers are huge and not fun. So guys, this is the second half of 5.3, factoring. And this is when, look, we had a 16 in front of that x squared. Okay, well, we can group. We had a 9 in front of the x squared. We had a 3, we had a 4, we had a 2. So if it's not just 1x squared or negative x squared, grouping is a great way to go to try to solve what these equations, and find x values that make them true. So I'm hoping this made sense. You might have to rewind. Now we're getting into some tougher stuff. You might have to rewind and rewatch a problem or two. If you have questions, write them down so you can ask them of me next time that we meet. But that is it for section 5.3, and we'll be going on to the next section next time. See you then.